Hello, my lovelies, it's Susanna, and today I want to show you how to solve 5 test questions from the SAT. We have approximately 1 minute per problem, and we have to solve everything without a calculator. So let's take a look at problem number 1. If a over b equals 2, what is the value of 4b over a? We get these possible solutions here. So we are allowed to use this, that a over b equals 2, and we want to find the value of this expression here. If we compare these two expressions here we have a in the numerator, here a is in the denominator, and b is here in the denominator, but here in the numerator. So we could flip both sides of this equation so that we get closer to this expression here. We can write the 2 as a fraction as well, so that we have 2 over 1. And if we flip both sides now, we have b over a on the left side, and here we have 1 over 2. Okay, now we have b in the numerator and a in the denominator. But the 4 is missing, but that's not a problem. We can multiply both sides of the equation by 4 here and here, so that we really have this 4b over a expression on the left side, and here we can calculate 4 over 2 equals 2. So now we see that this expression is equal to 2, and this is answer 2. Problem number 2. We get this function g of x that is equal to a times x squared plus 24. For the function g, defined above, a is a constant and g of 4 equals 8. What is the value of g of negative 4? So this time we get this function here, and they tell us if we insert 4 into our function, so if we take the 4 and insert it here for our x, then we get a result of 8. And the question is, what happens if we insert negative 4? So not the positive 4, but the negative 4. What happens if we insert it into our x here? Well, x is going to be squared, so the sign shouldn't really matter for the result, but let's take a closer look at this. So let's calculate g of 4. If we insert 4 into our function, we have a times 4 squared, and then plus the 24. And what happens if we insert negative 4 into our function? We have a times, and instead of the x, this time we insert negative 4. We square this thing as well, and then we have the plus 24. If we calculate this, 4 squared equals 16, and negative 4 squared equals 16 as well. So if we compare these results here, they are the same. So it doesn't matter if I insert the 4 or the negative 4, I get the same result every time. So the result is 8, they told us, so the result is going to be 8 as well, because we only have x squared in here, and then the sign doesn't matter. Number 3. If 3x minus y equals 12, what is the value of a to the power of x over 2 to the power of y? This time, one of the answers is the value cannot be determined from the information given. So we keep this in mind that this could happen. But for now, we take this expression and let's try and simplify it. And let's see when we can use this equation here. So let's keep this in mind that we have this information. But let's see what we can do here first. We have the base 8 here, and here we have base 2. It would be great if we had the same base. So the 8, I can write that with base 2 as well. I can write the 8 as 2 to the power of 3. This is 8, and then I have to take all of this to the power of x, and here I stay with my 2 to the power of y. Now I have my base 2 here. I kind of have my base 2 here, but I want to get rid of these parentheses here as well. And we are always allowed to just multiply these exponents here so that we have base 2 and 3 times x equals 3x. And I keep my 2 to the power of y here. So this is how my expression looks like now. And now the bases are the same, and there is a rule that tells me how to divide these powers now. I just keep the base as it is, and I'm allowed to subtract the exponents. So 3x minus y. 3x minus y. Do you remember that that was exactly what they gave us here? So we are now allowed to replace this by 12 so that we have 2 to the power of 12, and this is answer A. So we solved this problem, and let's take a look at number 4. On Saturday afternoon, Clarence sent M text messages each hour for 5 hours. And Malin sent P text messages each hour for 4 hours. Which of the following represents the total number of messages sent by Clarence and Malin on Saturday afternoon? Okay, so we have to figure out how many messages both of them sent in total. Let's start with Clarence. They tell us that he sent M text messages each hour for 5 hours. So if he sends M messages each hour, and he does that for 5 hours, then he sends in total 5 times M messages. So these are the ones from Clarence. And then we have to add the ones from Malin. He sent P text messages each hour for 4 hours. So if he sends P messages each hour, and he does that for 4 hours, then he sends in total 4 times P messages. So these are the total messages, and this is answer C. So let's take a look at the last problem. If this equation holds for all values of x, and a plus b equals 8. What are the 2 possible values for c? Okay, where does c come from? C can be found in here, okay. So we are interested in this value here, or the 2 possible values for c. They give us that a plus b equals 8, so we keep this in mind, that we are allowed to use this. A and b are part of the expression here and here as well. So maybe let's get rid of these parentheses on the left side, and then let's compare the 2 sides and see if we get any information here. So to get rid of the parentheses, we can multiply each element from the first parentheses by each element from the second parentheses. So we have ax times bx. We can do a times b first, so that we have ab, and x times x equals x squared. Plus ax times 7 equals 7ax, plus 2 times bx equals 2bx, plus 2 times 7 equals 14. This is the left side of the equation, and on the right side we have this stuff here, so the 15x squared plus cx plus 14. Okay, let's compare both sides now, because if we take a look at it, we have x squared here on the left side and a part with x squared here on the right side. We have parts with x here on the left side, but only one part with x on the right side. And then we have this 14 here and here. We are not interested in the 14, so we can also cancel it out on both sides. But we are interested in our c in the end. So c is the number that is multiplied by the x. And because right now on the left side we have x not in just one spot, but we have two parts with the x, we have to factor out the x here. So we have this x squared part, which is okay, and then we want to factor out the x here. So what is left in here? We have this plus here in between. And if we factor out this green x, only 7a is left. And if we factor out this green x here, only 2b is left. And on the other side, we also have a part with x squared and our part with x. So if we compare it now, we still have the x squared part here and the x squared part here. And then we have one spot where my x is this time, and here as well. And if I compare it now, I can see that my c has to be equal to this part here, because this is the number that is multiplied by my x. So this has to be equal to c if I compare the two sides. And my x squared part, I know that this number here is 15, so I know that this here in front of my x squared has to be equal to 15. So I will find my c if I know the values for a and b. And what do I know about a and b? Well, we know that if we multiply a by b, we get a result of 15. And additionally, they gave us this information here. Don't forget about this, that a plus b equals 8. So we have a system of equations, two variables. We can solve this for a and b, and then in the end, find our values for c. So let's take the system of equations here. We keep in mind how to find c then, but first of all, we have to find a and b. And because we don't have so much time during this test, I wouldn't solve the system of equations step by step, but I would try and just figure the numbers out. So we're looking for two numbers that if I multiply them, I get 15 as a result. And if I add these two numbers, I get 8 as a result. The numbers 3 and 5 do that. So if I take 3 times 5, I get 15. And if I add these two numbers, I get 8. So for my a, I can have the 3, and for my b, I can have the 5. But the thing is that this is only a first solution. A second solution would be the other way around. My a could also be 5, so that I have 5 times 3 here, and 5 plus 3 here. So my a could be 5, and my b could be 3. So that I have this pair here, and this pair here. Okay, let's find our c's then. Our first c would be 7 times a. So 7 times 3 equals 21, plus 2 times b. 2 times 5 equals 10. So this is 31. And before I take a look at my second value for c, I can see that 31 is only in here, so I already know that this is the correct answer. But let's calculate c2 as well. So 7 times 5 this time, which equals 35, plus 2 times 3, which equals 6. And yes, I get the 41 here as well. These are the two possible values for c. If you liked my video, please give it a thumbs up. It helps me a lot. I wish you a wonderful day, and I hope to see you in one of my next videos. Take care.